Hello everybody, we're getting ready to do lesson for pre-algebra math, chapter 9 review and summary, part 2, and let's get right into it here. So let's go right into an example for 9.3, the Pythagorean theorem. Find the unknown length c, so we need to find this length here in simplest form. So it looks like we got a right triangle, so we can use our Pythagorean theorem. A squared plus b squared equals c squared. To do that, we're going to plug in our values here. 8 squared and then 14 squared will equal c squared. Substitute 8 for a and 14 for b. And then we can solve them for c. 64 plus 196 will equal c squared. And then we take c squared equals 260. We're going to add these two together. So what do we do next? To find c. To find c, we take the square root of both sides. What's square root of 260? Would be 2 times square root of 65. So it'll be 4 times 65 and would equal c. And so the answer for the length c of the hypotenuse of the triangle will be 2 times the square root of 65. So let's try one now. We got to practice. Find the unknown length, which is b here. Write your answer in simplest form. Students, this is yours down here, so pay attention so you can do your independent practice in class, by the way. So for up here, we're going to use our Pythagorean theorem. A squared plus b squared equals c squared. Plug in our values here. We got 9. 9 squared. We got 7 will be our a. So it's 7 squared plus b squared equals 9 squared. And then 49 plus b squared equals 81. We subtract 49 from both sides. B squared equals 32. And then we take the square root of both sides. B will equal the square root of 32. B, we can factor out a 16. Square root of 16 times 2, which will become 4 times square root of 2. So the length of B in this situation here will be 4 times square root of 2 units. Okay, moving on now to our next example, 9.4, real numbers. So use a number line to order the numbers: negative 2.5, square root of 6, 17 over 8, 1.8, and the negative of square root of 2 from least to greatest. So graph the numbers on a number line and read them from left to right. Okay, so here they are: negative 2.5, the negative of square root of 2, 1.8, 17 over 8, and then the square root of 6 would be about there. Okay, so we got them on a number line. From least to greatest, the numbers are negative 2.5, negative square root of 2, 1.8, 17 over 8, and then the square root of 6. And so there it is there. Okay, copy and complete the statement using these symbols here, which is less than, greater than, or equal to. And put that in here to make this a rational expression here, an expression that makes sense. So we have the square root of 1.44 blank to 1.2. So what's the relation of this quantity to this quantity there? Students, this is yours down here. We're going to do this up here now. So to do this one up here, 1.44, so we got 1.2 here. 1.44 equals, the square root of 1.44 equals 1.2, which equals there. So does 1.2 equal 1.2? I think it does. So 1.2 equals, what you would put in here would be an equal sign to make this expression a rational expression. Okay, on to the next example, your 9.5, the distance and midpoint formula. So given points A, negative 5, 6, in the ordered pair here, and then B would be 3 and 8. Find the distance D between the points and find the midpoint M of line segment AB. So what we have here, here's our distance formula, equals the square root of x2 minus x1 squared plus y2 minus y1 squared. There's our distance formula. You should know that by now. So we're going to plug in our values. 3 minus the negative 5 squared, 3 minus the negative 5 squared, plus 8 minus 6 quantity squared. So we're going to substitute 3 for x2, negative 5 for x1, 8 for y2, and 6 for y1. And then once we do that, we have the square root of 8 squared plus 2 squared when we subtract out here. And then what's that? That's the what we have then is we have the square root of 64 plus 4, which is the square root of 68. So that is our distance formula between A and B. And then that can be further reduced to 2 times the square root of 17. Okay, so we have that. We have our distance. So yeah, we found our distance here. We got 2 different points here. Did we find M for the last one? I think we did. So for this one here, we have negative 5, 6, and then 3 and 8. Find the distance of D between the points. And then here again, we got our, now we're going to use our midpoint formula now for these 2 points. So we plug in. Instead of subtracting, we're going to add over 2. So negative 5 plus 3 over 2 will be our x coordinate for a midpoint. And then 6 plus 8 over 2 will be our y coordinate for our midpoint. And then we end up with a negative 1, negative 5 and 3 be negative 2 over 2 be negative 1. And this 6 and 8 would be 14 over 2 would be 7. So there's our midpoint there for this line. Okay, so our solution up here to find the distance between A and B and find the midpoint M of A and B. Well, first we're going to use our distance formula here, which we subtract between our x coordinates. So we're going to plug in here 6 minus 9 squared. And then our y coordinates as well, we're going to go 6 minus 10 quantity squared. All of this underneath a radical sign. So we have, this becomes negative 3 squared plus negative 4 squared. That becomes 9 plus 16, which is radical 25, which comes to 5. So there's our distance here between these 2 points is 5 units. And then our midpoint, we're going to add. Midpoint, you add x1, x2 over 2, and then y1, y2 over 2. 9 plus 6 over 2, 10 plus 6 over 2, we get 7 and 1/2 and 8. That would be our midpoint there. When x equals 7.5, y equals 8, that would be our midpoint on this segment AB. Okay, going into our next 9.6 here, special right triangles. So find the value of x. We need to find this value here. So how will we go about doing that? The triangle is a 45, 45, 90. The value of x, which is the length of the hypotenuse, this is your hypotenuse, it's opposite of your right angle here, is the product of the length of a leg and square root of 2. So with that, we have x equals leg times square root of 2, which equals 6 times the square root of 2 would give us our hypotenuse. So there it is there. Let's try one here now. Find the values of x and y. Find the values of x and y. Write your answer in simplest form. Students, this is yours down here. Pay attention up here. So anyway, up here, x and y. So the triangle is a 45, 45, 90. The value of y, which is our hypotenuse, is the length of a leg, is equal to, the value of x here, which is the length, this is x here, so which is the length of a leg is equal to the other leg. So we know that x will equal 11. We know that much. 45, 45, 90. So we know this equals that. So now we need to find y. The value of y, which is the length of the hypotenuse, is the product of the length of a leg and the square root of 2. So it would be, what would that be? What would that be? It'd be 11 times square root of 2, right? So it'd be y would equal a leg times square root of 2, which would equal 11 times the square root of 2, which would be y. Okay, let's move on to our next section here, which is 9.7, the tangent ratio. So find the value of m. We need to find this length here of m. We know this angle measure is 20 degrees, so we can use our tan ratio from our 20 degree angle. So tan 20, which would equal m, so it'd be opposite over adjacent would be the tan ratio. So m over 48, definition of a tangent ratio. So tan 20 would be 0.3640 equals m over 48. Then we just need to solve for m then from there, right? So from there we go 48 times 0.3640 is 17.5 would equal m. So our m length here would be 17.5. So let's go into our guided practice here. And triangle PQR with right angle at R. Angle P has a measure of 72 degrees. The length adjacent to angle P has a length of 8 units. Find the length of the leg opposite angle P to the nearest tenth. Okay, so what we should probably do with this one up here is draw a diagram. So here's our diagram here. And we have a right angle here at R. And then the measure of P of 72 degrees here, which would be angle P, 72 degrees. The leg adjacent to P has a length of 8 units here. So PR would be 8 units, right? Find the length of the leg opposite angle P. We need to find P here. We know the length of this is 8. So we can use our tan again, which is tan 72 would be opposite over adjacent, so it would be P over 8. And then we take tan 72 is 3.077 equals P over 8. We multiply 8 times 3.077. We get 24.6 would equal P. So here is our length of P right here using our tangent ratio. Okay, on to our next section here. 9.8 to sine and cosine ratios. Find the value of A. We need to find this. Round to the nearest tenth. So how are we going to find the length here of A? Well, we got a right triangle. We got a 40-degree angle here. So we can use sine. Sine 40 will equal A over 15. So we can set that up. What is sine? What is the sine of 40? Is 0.6428 equals A over 15. And then we're going to solve for A. So we multiply 15 times that, and we get 9.6 will now equal A. So there's the length of A. Multiply each side by 15. So let's do one here. Find the value of B in this triangle ABC. Students, this is yours down here. Pay attention up here. Round to the nearest tenth. So we need to find this length here of B. We got a 40-degree angle here. And we have a hypotenuse. So what are we to do to find B here? To find B, we're going to use cosine 40, which is adjacent over our hypotenuse. B over 15 equals cosine 40. Cosine 40 degrees is 0.7660 equals B over 15. Multiply 15 times that and you get 11.5 now will equal B. So there's your B. And that is your part 2 of chapter 9, review and summary. Email me at animatedpowerpointmathvideo@aol.com for questions or course materials. Thank you very much.